Welcome back, physics. Today we are going to be solving problems with projectiles launched at an angle. In front of you, you can see the image of our projectile. We have our vector triangle and then the total parabolic motion of our projectile. And so what we want to do is we want to find the horizontal range that a projectile flies based on its initial velocity. So I'm going to move my drawing just a little bit up here. And we want to start by making our XY table. So let's put that right in the middle here. X and Y. And we know that we have an acceleration in the x direction of 0 meters per second squared. We don't know what our x velocity is, and we don't know what our initial velocity is in the vertical direction. We don't know what either of these are. We also don't know our vertical distance up to the very height, or we could call this actually, let's call this distance to the apex. And then we also don't know the horizontal range or the distance in the horizontal direction. But we do know our acceleration in the vertical direction is negative 9.8 meters per second squared. And then we know our initial velocity and the angle that it's launched at. So based on what you have worked on so far in terms of triangles and how to find the different sides, take a moment. I want you to find out what the horizontal component is and what the vertical component is for a 30, 60, 90 triangle. All right, so we should know that the VY side is the A side and the 14 is 2A. So if I want to solve for A, I have to do a little bit of algebra here, and I will do that just to the left. So if that is 2a equals 14, then I can solve for a by dividing both sides by 2. These cancel, and I'm left with 7. So I know that my initial velocity here is 7 meters per second. And then the Vx side is equal to a square root of 3. In this case, I know what a is equal to. So all I need to do is multiply by 7 by the square root of 3, and you should get. So if it's a square root of 3, it should be 7 times the square root of 3, and that should get you 12.12. 12.12 meters per second. All right, so now we have the two components of our triangle, and we can start to solve this problem. Just to point out, we can't start solving this problem until we have these components because the two directions, the vertical and horizontal motion, they don't interact with one another. So we have to split it up because that 14 meters per second is moving both horizontally and vertically. It's moving in two dimensions. So we first have to split it up so that we can then start to deal with the two different sections. All right, so when we're looking at our notes, the next part says we ultimately want to find the distance in the horizontal direction, right? So we want d sub x. This is our unknown. And there's only one equation, which is helpful for us since we have a constant velocity, and that's going to be the equation velocity in the x times time. Now, the issue is we don't know the time of the flight. So because that is a problem, we are going to have to go onto the vertical side and find out how much time our projectile is in the air. So the first step to doing that, if I want to find time, I should remember that time going up to the apex is the same amount of time coming back down. So I can write that the total time, I'll write uh, t sub t for time total, is equal to 2 times the time to the apex. So if I can find the time to the apex, then I should be able to find the total time here. Right? So what I can do is I should know that right the velocity in the y's got to go up and then it's got to go down. And at some point it's going to switch spots and it's going to become 0 meters per second. And that velocity of 0 is always at the apex or the peak of its motion. Right? If it's moving upwards, it's got a positive velocity. It's getting smaller and smaller and smaller. And then if it's moving downwards, if its position is decreasing, then it's got a negative velocity. And so at some point, it's got to pass through 0, and that's the apex. You can do this on your own by just tossing a baseball or whatever object in your hand. Probably a pencil is pretty good too, right? You can toss it up in the air. You can see that at the very top of its motion, it stops for just an instant, but then accelerates downward again and continues to accelerate. Even at that 0 meters per second, the acceleration is still negative 9.8. Just because the velocity is 0 doesn't mean that the acceleration has stopped. It's still accelerating the entire time. All right, so if we want to find the time to the apex, we can use the equation velocity final minus velocity initial over acceleration. Because we know the initial velocity of 7, we know the final velocity of 0, and we know the acceleration to be negative 9.8. So we can plug in our numbers here. We have a final velocity of 0, because that's where we're looking at. We're looking at the velocity at the apex as the final. Then we subtract the 7 meters per second divided by negative 9.8, and take a moment to plug that into your calculator. And you should find the time to the apex to be 0.71 seconds. Sweet. So now we multiply by 2. 2 times 0.71 seconds should give us 1.42 seconds total. So this is our total time. And now we can plug it back into our original equation for distance on the left side here. So it's going to be distance in the x is equal to our velocity of 12.12 times our time in the air of 1.42 seconds. Gives us a total time of 17.2 meters. Actually, I'm going to draw that down below. Distance in the x is equal to 17.2 meters. And that's our final answer. So these are some really quick notes on how to solve these problems. So just to review what we did, we started off by finding our different components of velocity. The next thing is we identified the equation that we needed to solve, and we found out that the time was unknown. Since constant velocity would get a little cyclical in terms of solving for time, we are actually going to move from horizontal numbers over to here to find time. So that's what we do. We find first, though, that the total time is going to be equal to twice the time to the apex. And to find the time to the apex, we use the velocity from the apex as our final. So it's 0 minus our initial over the acceleration. We get that time to the apex. We multiply by 2 and get our answer of 1.4 seconds. Plug it back in, and we get our final answer of 17.2. So this is how you solve these problems. Take your time as you solve the homework and be careful, right? There's several steps to this. It's much more complex than problem solving we've done in the past. And check your answers as you go. All right, see you later, physics.